papers, and so this is feedback from your teachers, which have generally said that these are the questions that you did not do so well in, hence why I have created the video for you. Now, of course, all of these questions that I'm going to go through are accompanied by a question that has been selected for you, so it's worthwhile you watching this and then attempting each question individually, but it does depend on how you do things, so it is your choice. So the first question Mr. Sen is going to deal with is question number 1B, which is to do with the banned substance ECO, if I remember, EPO, my apologies, EPO it is. And the question says, blood doping is a way of cheating in sport. The drug EPO increases the amount of hemoglobin in the blood, and explain why taking EPO gives athletes an unfair advantage. Right, if you've got too much hemoglobin in your blood, think logically. Remember, there's 2 marks for this. Think logically. There are 2 marks. So one must be that hemoglobin, remember, carries oxygen. So if you've got the drug EPO increasing the amount of hemoglobin in your blood, then that means that you're going to be able to carry more oxygen. Okay. So if you're carrying more oxygen, this gives your muscles a much more, a much greater opportunity to respire, and so you'll get less fatigue and you will have more energy. So remember, anything that you missed in what I said, please endeavour to look over on the right hand side. You will always find the mark scheme to accompany the question I'm going through. Okay, so that gives you an example and an answer for this particular question, question 1B. So moving it on to question 2. Oh, this is an interesting one. Okay, now this is to do with the breeding, the crossbreeding, I should say, or the selective breeding, I should say, of not crossbreeding, selective breeding of pugs. So let's have a read of the question. Look at the pictures below. Here's a grey wolf. Here is a pug. Probably one of the cutest / least attractive dogs that I know of. But, you know, I'm not a pug lover, but there are many pugs out there that I'm sure appeal to a lot of people. But you can see that there's a clear difference between the nose shape of the grey wolf and the pug. Now, interestingly, the grey wolf is a wild animal, and all dog breeds like the pug are thought to have been bred originally from the grey wolf. Interesting, isn't it? I mean, how this could be the ancestor to this organism here. This is how much the features have been selectively bred out from the original animal to the current animals that you see here. Notice that I did mention the nose idea, which is a clear difference here, because the question itself is going to be dealing with breathing problems. So let's have a read. As a result of selective breeding, some pug dogs have breathing problems. A bit like myself today, as I'm sporting a lovely cold. Suggest why pug dogs have breathing problems and explain why continued selective breeding could result in other health problems. There's 2 parts to this question. Put a slash through the word and, because the first part is suggest why pug dogs have breathing problems. Let's deal with that first. Okay, look at the pug. It has a very, very short nose compared to the grey wolf, which is its ancestor. This shorter nose, obviously, or this squashed or flat face that it's got, is going to be causing breathing difficulties because it is going to have shorter nasal passages. If it's got shorter nasal passages, the idea is going to be that this organism here is not going to be able to take in enough oxygen. And as a result of that, lo and behold, it's got breathing problems. So that would definitely tell you some ideas about why the pug has breathing problems. So if we look over here at the mark scheme, identifies reasons for breathing problems. This is for top marks. Remember, over here, level 3 is top marks. So when we're talking about reasons for breathing problems, that has already got you some way to getting top marks. The second set of marks is going to come from the linking of detailed selective breeding to other health problems. So suggest why pug dogs have breathing problems, we've dealt with that, and explain why continued selective breeding, I'm obsessed with breathing today because I can't do it myself, could result in other health problems. Right, now, okay. if you are breeding an organism so it changes so much down to these features that you've got here, or these features that you've got here, you need to understand that when you get a litter of pups and you get, let's say, a litter where two of your pups have got really flat noses and one of those pups is a female, one of those pups is a male, what do you do if you want to pretty much increase the chances, not guarantee, but increase the chances of having an even flatter nosed pug? Then you breed that sister and brother from that very same litter together. Now, you know as well as I do that that is going to create a reduction in the gene pool. And that will then lead to the accumulation of harmful recessive characteristics. This is why you don't sleep with your relatives or reproduce with your relatives on the whole. And that is because it's, certainly brother and sister relationships, they are too close, far too close. And as a result of that, ladies and gentlemen, harmful recessive characteristics build up, and therefore there's a reduction in variation and a greater likelihood of disease. Okay? Disease. Other things include, well, if you're trying to breed something so that it's more intelligent, you might, for example, more intelligence, because you can breed organisms or animals for their intellect, of course, you may end up with a situation, an unwanted example here, where the dog that is made more intelligent might actually end up being more aggressive, more violent. Yeah? So, you've got to be very careful. So, for more details, remember, identify the reasons for breathing problems. That's going to be identifying the breathing problems. Reasons for breathing problems, remember, we've already said that, the shorter nose, the flatter nose, and so on and so forth, and links detailed selective breathing to other health problems. I've talked about, and it does also talk about actually here, aggression and intelligence, for example, and you should be really talking about the idea of genes and the gene pool being too short and small for effective prevention of disease. All right. So for more details, please have a read of this. I know these 6 markers seem horrendous. This is what you need to look at first and foremost, and then look at what they're expecting for level 3. Okay. They're also expecting for level 1 and 2 aspects of these here. Okay. But to get top marks, remember you need to include that and something from here. Okay. So that is your exemplar of how to answer a 6-mark question. Okie dokie. Here we go. Question 3A, part 2. This is to do with enzymes. All right. So this is how does a lock and key mechanism explain why pepsin. Let me just tell you what pepsin is. Pepsin works in breaking down proteins, and it does that in the stomach. So it works at a very low pH, which means it works in very highly acidic conditions. And remember what I said, it only breaks down proteins. So how does a lock and key mechanism explain why pepsin will only break down protein and not other food groups like starch? Straight away. I've clicked my fingers, straight away know the answer to this. Starch is a carbohydrate. Let me put this mark scheme up here for you lovely children. Starch is a carbohydrate. Remember, if you want to pause it, you can have a look down here at any point. Starch is a carbohydrate, and a carbohydrate is not a protein. Starch will be a different shape as a substrate. There's a substrate there. As a substrate, starch, where are you? Starch will be a different shape to the protein. And therefore, it will not fit in the mouth of pepsin, which is known as the active site. There's the active site of pepsin. That's the active site of pepsin. And protein is exactly the right shape to go into that active site. You can see that happening there. And you can see that the pepsin enzyme will break down the protein into smaller amino acids. So will starch be the right shape? Sorry, will starch be the same shape as the protein? The answer is no. And therefore, the key wouldn't fit the lock. Simple as that. That is the lock and key mechanism. For more details, have a look over here on the right-hand side. Okie dokie. So next one, folks, is question 4A. Okie dokie. Oh dear God, right. The balancing equations is always very difficult for me to do online. So your teacher may have to pause this and go through this with you at some point. But I will try my very hardest over here. Pete and Helen investigate the reaction between sodium carbonate, which is represented by the symbol Na2CO3, and ethanoic acid, which is given by the formula over here. Sodium ethanoate, which is given over here, carbon dioxide and water are made. Complete the balanced equation for the reaction. Right, look at this logically. It is so simple because all you have to do, you've been told that these two things are reacting together to form that one, and that one. So you put that formula there, so that becomes C2H3, O2, and A. Carbon dioxide, just convert that into a simple equation, and that's CO2, kind of obvious. You've done this many times before. And water is H2O. So just by doing that, looking at the question and putting it in here, that gives you 1 mark. Now, the next mark comes from the balancing of the equation. Okay? And in summary, remember, everything before the arrow has to equal the same number as after the arrow over here. And if you want to look very, very carefully, you need to put a 2 in front of the sodium ethanoate and no numbers in front of the carbon dioxide and water. And the reason why you need to put a 2 in front of the sodium ethanoate is if you look over here, there's 2 times 2, which is 4 carbons. But if I left that as it is, there would only be 2 carbons. So you obviously have to put 2 in front of the compound, which multiplies everything in the compound by 2. All right? Okay, by 2. So that has a knock-on effect to the number of hydrogens. That would become 6. But if you combine that with the 2 from the water, that becomes 8. And let's see if now we know after the arrow is 8, we know that before the arrow must also be 8. So 2 times 4 is 8. Just that's what you need to keep doing as you look through it, and lo and behold, you will find that it has been balanced. Okay, folks. So 4C is the next little baby that you found difficult. Right. Look at the graph for the cold acid. Calculate the rate of reaction during the first 1.5 minutes of the experiment. Give your answer to 2 significant figures. All right. There's 1.5. Take a ruler, draw it all the way up to the cold acid line. Read it across, and that is 0.68. 0.68 divided by 1.5 gives you 0.45 grams. Okay? Per minute, sorry. 0.45 grams per minute. If you just put 0.68 divided by 1.5, you only get 1 mark. If you put the correct answer, lo and behold, you will have had full marks. Okay? And remember, you need it to 2 significant figures, so there's 2 decimal places there. Okie dokie. Oops, sorry, guys. Sorry. Right now for 5A. Okie dokie. For 5A. Right. Oops. I don't want to add a sticky note. Thank you so much for the offer there. Soldiers use flameless heaters to heat their meals. The flameless heater heats the food safely and quickly without the flame. It's useful. The heater uses a chemical reaction between magnesium, metal, and water. That's magnesium, metal is all one thing, okay? Magnesium, metal, and water. Use the balanced symbol equation to show that mass is conserved during this reaction. Okay. The relative atomic mass it tells you the masses, the relative atomic mass is there. Magnesium is 24, okay? 24, add 2 times 2 is 4, add 2 times 16, which is 32. 32, oh, what am I doing? My words, seriously, guys, I don't even know what I'm doing anymore. This cold is killing me, my apologies, guys. 24 is the mass of magnesium, my apologies. Then let's just make it simple. There are 2 hydrogens here, and each hydrogen has a mass number of 1. there is one oxygen there, so that is that has a mass number of 16. So 16 add 2 is 18. There's 2 times 18, which is 36 here. 36 add 24. Okay, 36 add 24 would give you 60. Over here, if you also calculated magnesium, which is 24, add oxygen, which is 16, but remember that's in brackets, so times that by 2. 16 times 2 is 32. 1 times 2 is 2, so 32 add 2 is 34. 34 add 24 is 58, and add 2 is 60. So there's 60 here, and there's 60 here. So that tells you mass is conserved. Simple as that. All right? So hopefully that should be clear as mud now. Remember, you can have a look over here if you need to have any more expansion on that detail. Number 7. Ooh, what beholds? Here we go. This question is about work and power. Oh, now this is riveting. Jana walks upstairs. Well done, Jana. Your 2017 exercise goals have been fulfilled. Right, the height of one stair is 0.15 meters. Right, straight away, you now know that that's 1.5. So 0.15 meters here. Jana's her parents called pajamas, and she has been called Janas from here on in. Well, Jana walks up 4 stairs, and she has a mass of 50 kilograms. Okay. So she walks up 4 stairs, so that's 4 times 0.15, which is 0.60 meters. Okay, you know that, right? Oh, hold on. Let me just move this down so you can follow what I'm saying. So I've done this bit here. So 0.15 times 4, and I told you that was 0.6 meters. Okay? She has a mass of 50 kilograms. Assume that the gravitational field strength is 10 newtons per kilogram. Calculate the work done by Jana using this data. I'm going to take you up here. Okay? Right. Where are we? I'm looking for the work done formula. Have I gone past it, or am I going blind? There we go. I am going blind. Work done is force times distance. So put that into a formula triangle. In fact, I don't even think you need to work it out into a formula triangle. You've got the formula there. Force times distance. Well, force is measured in newtons, but they've only given it to you saying that Jana was 50 kilograms. So 50 kilograms times the force of gravity on Earth would give you 500 newtons, and the distance she went was 0.6. So 500 times 0.6 gives you 300. And so the work done by Jana was 300 joules. Let me take it over here so you understand what I'm saying. There you go. Yeah, so 300 joules. Now watch. So 0.60 times 50 times 10, which is 500, and that gives you 300 joules. That's for 3 marks. Okay, folks. So that should be clear as day for you there. And finally, question 10C. And question 10C is here. Right, okay. 10C. Taryn's friend Charlie has a van. Oh, you little rebel, Charlie, my word. Charlie's van has double the mass of Taryn's old car. Charlie says that when my van goes twice the speed of your car, it'll have 4 times as much kinetic energy. Is Charlie correct? Explain your answer. Right, Charlie's van's double the mass. Let me make it quite clear. Only doubling the speed, right, of an object will multiply the kinetic energy by 4. So doubling the speed quadruples kinetic energy. Doubling the mass only doubles the kinetic energy. Okay? But doubling the speed and doubling the mass makes kinetic energy 8 times greater. Okay. Does that make sense? So hopefully, ladies and gents, that should be all of your questions answered. And I hope that you found that video useful. Please, of course, like and subscribe the video because that's very important, because whenever I post any more videos on here, all of which are going to be to do with your papers, to do with your revision, to do with assisting you in revising for your exams, including creating videos like there's already one on covalent bonding on there, which you can also have a look at. I will be doing more of those. And why am I doing that? Because I really do care for your education and I want you to do well. And hopefully you have equal, or if not higher, if not higher, expectations and desires for your own performance in science. So hopefully, guys, that will help you greatly. All right, so best of luck, guys, and take care. Happy revising. Bye-bye.